So, in order to be able to understand what molecules actually look like, we're going to have to start at the very bottom. That is, drawing dot diagrams. What are dot diagrams? Dot diagrams are visual representations of atoms showing their outer shell electrons that they have. It's developed by an actual American scientist, Gilbert Newton Lewis. The first time I saw his picture, I thought to myself, I've seen this guy before. And it took me a little while, and then I realized, he is the Lorax. So, let's write the dot diagrams for the first 11 elements. This is how we're going to do it. We're going to show you a generic element X. The S electrons are going to go here in the form of dots. Then we have 3 p orbitals, each containing 2 electrons. So we're going to place them there. No, I'm just showing you where they're located. Folks, this is easy peasy lemon squeezy. But you're going to have to see the pattern. Once you get the pattern, no one struggles with this. No one struggles with this. All right, let's begin with hydrogen. Hydrogen has 1s1. It has 1 electron in the S. So we put down the symbol for hydrogen, and we put down a dot to the right to symbolize it has 1 outer shell electron. Next column, helium, 1s2. Okay, I know that on the periodic table it's way off to the other side. That's because they like to put helium in with the other gases that are like it, noble gases. But really, you could also think of helium as being right beside hydrogen as well. I've seen periodic tables that have helium right beside hydrogen. So you would place the symbol with 2 dots. Now, in order to go to lithium, I'm going to go right back here. Why do I go down there? Because even though lithium has 2 extra electrons in the form of helium's insides, what does his outside look like? 2s1, just like hydrogen. So we would put down lithium with a dot, just like hydrogen. Beryllium is helium and 2s2, so beryllium is going to be just like helium in that you have 2 dots. All right, let's go into uncharted territory, unexplored space. Boron. Boron has helium's insides and then 2s2, 2p1. Esther, describe boron for me. The dots. Yes. Boron has 3 outer shell electrons. Carbon. Morgan, go.
Wait, I have a question really quickly.
Yes.
So, does it matter if like, you put the dot on top and bottom, or
No.
as long as there's like 3?
As long as it's 2 and 1.
And you don't include the previous, like...
Helium, no. Helium is inside. That's not important. That's why we learn condensed, because helium, those noble gas insides, are the electrons that never get taken, never get added, never get lost. All right, so what would carbon look like? Remembering Attila's rule. Go.
Well,
You're in the 4th column, so you're going to have how many outer shell electrons?
4,
Where?
2, 3.
Wrong, because you forget Attila's rule. Who's Attila? Attila was a warlord Asian warlord. His whole name was Attila the Hun's Rule. Did you forget Hun's Rule? What is Hun's Rule? Morgan, go. Give me Hun's Rule. You don't remember Hun's Rule.
Is that where you have to like fill up each room with one until you put a second in the...
Hun's Rule. Because you got to fill up each type of room first. S room gets filled up. And then we go, and you have 3 P rooms. Those P rooms have to be filled up with 1 electron before you can go back and fill them up with 2. Allison, add to get number 5. Nitrogen. Follow the pattern. Yes? Yes? Very good. Morgan, back to you. You can redeem yourself for forgetting Hun's Rule. Oxygen, go.
Okay, hold on, I gotta look at it. So you do 2,
Yes?
and then it comes. So 1, 1, and 1.
Okay, that's the same as nitrogen. You have 1 more electron to play with.
Oh, wait.
Oxygen has 6. Nitrogen had 5. You have 5 now.
Okay.
You have 1 more to go.
So you put the other one on. Wait, why does it matter?
It doesn't. Just decide.
Can you just put it anywhere?
Yes, northwest or south. Thank you. Ruth, go. Follow the pattern. Keep it going. Oh, she's getting all fancy and cartographical. Cartography, the study of maps. What? 2 to the north. 2 to the west. 1 to the south. Excellent. 8. Noah, go. Give me 8.
Like any of the...
No, like neon.
It would just be 2 dots on the top, the right, left, and the left.
And then, Elizabeth, give me sodium. Watch where I'm going to put sodium. Marco, give me magnesium.
I have 2 dots.
Natalie, give me aluminum.
3 dots.
Show me where.
2 to the right, 1 on top.
Are you guys beginning to see a pattern? Max, silicon.
2 to the right, 1 on top, and 1 to the left.
Very good. Grant, show me phosphorus.
I got 2 to the right, and 1 on every other side.
Very good. Simon, show me sulfur.
2 to the right, 2 on the top, 1 on the left, 1 on the bottom.
Good. Ryan, show me chlorine.
2, 2, 2, 1.
And finally, Max, have you done one? Sasquatch. Sasquatch, show me argon. Folks, do we need to go to potassium?
No.
The pattern will repeat itself. Now, wait a sec.
What about the lengthenized?
Okay, hold on. So, this is potassium, this is calcium. What about scandium?
Don't you have to do 1 less?
Nope. Scandium. What about titanium? What about tungsten?
They all have 2. They all have 2.
What have I told you multiple times? The transition metals are inside
Sorry, wrong letter.
inside the second column. And the F's are inside the D's, which are inside the second column. So all transition metals, all lanthanines, all actinides have 2. That's not exactly true, but for now, let's just make believe it is true. All right, so let's take it to the next level. Let's learn how to draw dot diagrams for ionic compounds. Since positive ions lose electrons, they will lose all their outer shell electrons. So we place them with a bracket and a charge. Let me give you an example. Calcium has 2 dots. Why? Second column. This isn't hard. Calcium's goal is to have 8. It has 8 inside. It's argon. And then it has 2 more. So its choices are, it has 2 choices. They are lose 2 or gain 6. Okay, path of least resistance would tell us that it would lose 2. So when it loses 2, it loses it from the outer shell. So it would appear to us as it's just Ca. But that can be kind of confusing because that's just a symbol. So the way that we tell people, communicate with people that we're dealing with dot diagrams is by leaving it what I like to call naked, which is in East Tennessee means that boy does not have any clothes on. All right, naked, totally naked of any electrons with brackets and a charge. So you got to have brackets, you got to have a charge. You got to have brackets, you got to have a charge. And then the metal ion. What's another name for a positive ion? A cation. Cation. All right, let's do some more cations. Molly, sodium. What is sodium normally? No. How many dots does sodium normally have? 1. But when it becomes a cation, what will it look like? Did you say Na?
Yeah.
Oh, okay, I'm sorry, I didn't hear you. She's right. It loses the 1, and when it loses electrons, we say that it's +1, and we put brackets there to alert people that we're dealing with a dot diagram. Yes?
What if it's 4 and you could either lose 4 or
We don't play with those. Don't play with those toys. Those are not good toys.
I like those toys.
Nope, don't play with them. Fine, you want to play with them? Play with them.
Are we going to learn about that? Like, if we do able to learn about that?
Not really. Those elements like carbon and silicon tend to form covalent molecules, which is what we're going to learn tomorrow. Okay, here we go. Magnesium with 2 dots. Marieli, show me it as a cation.
Wouldn't it just be energy from brackets plus 2?
It would be. And finally, aluminum, Elizabeth.
In bracket, Al, bracket plus 2.
Excellent. All right, so we have positive ions. These are atoms that have just a few electrons. They'd rather lose electrons than gain them. But there are such things as negative ions. What's the other name for a negative ion? Anion. You will still need to use a bracket and a charge, but where we lost electrons, now we gain them. Yes, Ryan?
How would you do elements like iron with those?
Just 2 dots. Just keep it simple. You wouldn't need to. Don't worry about that. Okay? Here we go. Selenium. Dot, 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 dot. Alec, show me selenium as an anion.
So you
Put it in the thingies, better known as brackets.
and then it's -2.
-2. Okay, you need to understand, cations are naked, not anions. Anions gain electrons. They don't lose them. Well, so it's naked. It doesn't have any electrons. It needs to be full of electrons. Yeah, you gotta have. Put clothes on them.
This is like a fashion show.
You funny.
Phosphorus, Phoebe. How many electrons?
It has 2 and then 1 on each side.
Show me phosphorus as an anion.
It would be phosphorus in the brackets -3, and you would have the 2 and 1 on each side.
Wrong, because it's not gain 3 at that point.
Wow.
You said you were right. It needs to gain 3, but you didn't let it gain 3.
So you always just put the element with 8 in the bracket?
Yes, anions always have 8.
Is it never possible to have more than 2, like on its side?
Right, because of what is it? Heisenberg's, no, not Heisenberg's, Pauli's exclusion principle. Only have 2 in each orbital. Sulfur. Morgan, go.
Oh no, okay,
Sulfur, how many?
wait. Gotta look at my notes. So, oh wait, we didn't know that. Okay, one, 2, 2, wait, I gotta think about it. 1 and 1.
Okay, so when it becomes an ion, what will it look like?
There's an S in the bracket. And then it's -2. And then, so this is something like you have to add.
Okay, it normally has 6 dots. -2 means you gain 2.
Yeah, so you'd have 2 on each
My
side.
clicker.
I'm making X's. Electrons can be denoted by X's or dots. What I'm doing is giving you 6 X's and 2 dots to show you that those are 2 new ones.
Okay, I see you.
Finally, chlorine. Natalie, go. Normally, chlorine is
2 there, and 2 on top, and 2 on that side, and then 1 on the bottom.
but when it becomes an anion,
It's the brackets, and then CO, and then 8 -1.
in review, the metal will be naked and plus. The non-metal will be full and minus. Okay? All right, so let's do one of these. Magnesium chloride. The first one we're going to do nice and slow so that you understand the concept behind it. And then I'll show you how to do it quick and dirty. All right, we're going to use Mark and Natalie and Elizabeth in this example. They're going to play the part, and they're even oriented just perfectly for it. All right, here we go. This is Mark. How many dots does Mark have, Mark?
2. Red dot.
Okay. Natalie, you can be chlorine. How many dots does chlorine have?
7. Why am I X's?
Would you rather be dots?
No, it's just I was wondering.
I'm just showing you those are your electrons and those are his electrons.
Okay.
Okay, so Mark, what do you want in life?
Money. Happiness.
You're metal. You don't have any use for money.
Be positive. Negative. You want to have 8. Wait, I want to have 8. Sorry.
Okay, so right now you have 8 inside and you have 2 more. So are you happy?
No. Wait. No,
No, you're not happy.
I'm not happy.
Don't let them. Natalie, what do you want in life?
To gain another electron.
To gain another electron. Okay, so he wants to give up 2 electrons. Natalie, you want to gain an electron. So why don't you guys talk about things? Maybe we can come to an agreement.
It's a win-lose.
You can have
But then I only Somebody has to lose.
Okay, Mark, talk to her. Be a man about this.
Give me 6 of your electrons.
Mark.
Okay, are you going to give him 6 electrons?
No, that's stupid.
Okay, so that's not going to happen, Mark. So what alternative do you have?
Give you 1 electron, 2. I can only give you 1.
Okay, here's the problem. Natalie, he's willing to give you 1. Is that okay with you? Okay, but he's got a problem. What's your problem, Mark?
I still have 1.
He still has an electron.
That's his problem, not mine.
But I mean, just because you're satisfied, don't you feel bad about him?
No, not at all.
Well, forget it. He's not going to give you that electron that will satisfy you unless he gets to get rid of 2. So you're going to have to solve the problem, Natalie.
Another chlorine?
Hey, Elizabeth, you're a chlorine too, aren't you?
Mark,
He got 2.
Okay, now, why don't you 3 get together and, maybe you can make some magic occur. Talk about it. Go.
I'll give you each an electron.
He's willing to give you an electron, Elizabeth. And you too, Natalie. What are you going to do about it? Yeah? Yeah? All right! So,
This is with other metals.
this is on YouTube, guys. If you don't care, I don't care. But, all right. So, there's Mark's dot and Elizabeth. There's Mark's dot. What do we do with Elizabeth and with Natalie?
Mark, look what you did to Ryan.
There it is. Guys, stop it. All right. That's the dot diagram for magnesium chloride.
I liked it better when we just had to write the charges.
That's really nice. Let's go on. Now, let me give you the quick and dirty method. All right? Esther, you can help me. What is the chemical formula for aluminum oxide? Very good. All right. So, which one's your metal? Esther? Okay. So, how many aluminums do you need? And what will metals look like? Shh, hush! What? And what is the charge on aluminum? Which one? Plus or minus 3? All right, and what do we do with the oxygens? The girl can see patterns. That's it, folks.
Hey, I got
That's it.
barium oxide.
All right, Morgan, go. What's your question?
How many are on each side?
8.
2 on each side to make 8.
Yeah, no,
2, 2, 3.
Oh, the line. Okay, sorry.
All right, barium oxide. Go, Ryan.
Ryan.
Is barium the BA?
Yes.
Alright, so that's a plus 2 oxide plus 3. You need 2 bariums.
Okay.
Alright, and you put them in the bracket things. See, I thought we were doing the hard way. And then you put 3 oxygens.
Okay.
Oh wait, oxygen's in the -2 section. Erase one of the bariums.
Okay.
Erase 2 of the oxygens.
Okay.
Put electrons all the way around them. Alright, there you go.
Boy, that was an adventure, but he got it right. I have to applaud you. That was excellent. All right. So that's how you determine the dot diagrams for ionic